Okay, two boxes A and B are connected by a light cord and are resting on a smooth table. Okay, alright, so the boxes have masses 10 kilogram and 12 kilogram. Okay, a horizontal force of 14 Newton is applied to 10 kilogram box. Okay, that means this 10 kilogram is being pulled to the right with 14 Newton force. Yeah, 14 Newton pulling force. Calculate acceleration of each box and then the tension in the cord connecting the box. Okay, so let us look one by one. First of all, he says that they are resting on a smooth table. Smooth table, that means this is a smooth surface. If smooth surface, no friction. Okay, or we can say the friction is equal to 0. No friction. And then they have mass. This is which one? This one is mass A. Mass A. Maybe A I put as number 1. A as 1. B as A as mass A I put as mass 1. Mass B I put as mass 2. I like number better because number easier to write, yeah, compared to alphabet. So this is mass A, 10 kilogram is mass A, which is mass 1. This is mass 2, yeah. Mass B is mass 2, 12 kilogram. So they have the weight, yeah, they have the weight. And this is the external force, 40 Newton. Now acceleration of each box. So we know that these two boxes, they are connected to each other, so they should have the same acceleration. They should have the same acceleration. They should share the same acceleration. No box is accelerate faster than the other. Both boxes which connected by a string, they should accelerate at the same acceleration. They should have the same acceleration. Okay. You see, we only have one answer for acceleration. That means both blocks have the same acceleration because they're connected by the same string. Okay, so now here how many objects we have? How many objects we have over here? We have 2 objects, isn't it? So here 2 objects. If 2 objects means we must have 2 FBD. We must draw 2 FBD separately. Okay, 2 objects, not including the string. 2 objects means we have 2 free body diagram. Okay, so let us first identify what kind of forces exist for each box. Yeah, what kind of forces exist for each box? Look at mass 1 first. Mass 1, okay, this is the this is the point mass. Okay, this is the pulling force FP. FP. This is the weight W1. Okay, mg, and this is the normal force because it's resting on the surface. So the normal force is perpendicular to the surface. This is N1. Understand? Okay, this is N1. And what else? Yeah, the tension. You see, in between the two blocks, they have this action-reaction force. Still remember what I told you about the Newton's third law? See that? This Newton's third law, every action has a reaction force at equal in magnitude but opposite direction. So like this block, it has TBA. Like block A has TBA, block B has TAB. So this TAB and TBA, they are equal. They are equal in magnitude, but got one negative sign here, means they are opposite direction. You see that? TBA acted on block A, TAB acted on block B, but they have the same tension, although they have different mass. They have the same tension. These two forces, they act on 2 different objects. They act on 2 different objects. Yeah, one tension for block A, one tension for block B, and same string, same tension. Okay, same string, same tension. Go back to that example just now. So in between the string here, we can say block block A is pulling block B to the front. Yeah, pulling block B to the front. But block B also dragging mass A behind. Yeah, dragging mass A behind. So I can say A pull B, B also pull A. Okay. Okay. Now look at A first. Look at A first. So A should have a tension to this direction. So this tension should put as what? Who experienced this tension? Block A, isn't it? Block A. So block A, you should put okay, you should put as A behind. Yeah, A behind. That means this is TBA. This is TB on A. TB on A. Okay. That TB. What is mean by TBA? What is mean by TBA? Let me write it down. Yeah. Okay. So what is TBA? TBA means the mass B is dragging mass A behind. Is dragging mass A behind. So without mass B, actually mass A can go to the front much easier. Yeah. So mass B is dragging the mass A behind. So that's why the tension TBA is going behind. Yeah, going behind, opposite the acceleration. Okay. That's no friction, right? Smooth table, no friction. I think that's it for mass A. Now look at mass B. Mass B, okay, let us use the blue color instead. Okay, so mass B, what kind of force it has? Okay, draw a point mass first. Okay, it has the weight 2. All right, it has the weight 2, and it has the normal force 2. Remember, this one you should put W1, W2, normal force 1, normal force 2. Don't you go to put normal force only without the subscript. Don't write WWNN without the subscript. Yeah, cannot, because they have the different weight. They have different weight. You need to identify them with different subscript. Understand? You need to write W1. You need to write you need to write W1, W2, N1, and N2. Okay. Yeah, cannot just write WWNN. Cannot. Okay, and then what kind of force you have here for mass B? Like you see, just now I say B drag A also drag B, isn't it? A also drag B. So A actually, the mass A actually pulling mass B to the front. It pulling mass B to the front. So mass B experience this pulling force to the front. Experience this pulling force to the front, which is this one should be TAB. That means this one is TA on B. TA on B. Who experienced the force? B. Always the number B. You see the alphabet behind. Always the alphabet behind. Show who experienced the force, right? Like this TAB, the alphabet behind is B. So mass B experienced this force. Like TBA, the alphabet behind is A. Okay, alphabet behind is A. So it is the mass A who experienced this force. Okay. This is okay. Maybe I should write it down here. This one is TA on B. Okay. And this one is TB on A. Okay, TB on A. This one is TA on B. Okay. So what is TAB? Let me write down for you. Okay. So again, TBA is the mass B dragging mass A behind. So that's why this TBA is going behind. This TBA experienced by mass A, yeah, being dragging behind. This TAB is the mass A pulling mass B forward, to the direction of the external force. Pulling mass B forward. That's why TAB is going forward. You see, going forward. Yeah, this force TAB experienced by mass B. Okay, and this TAB and TBA, they are equal. Same force. I can say in terms of magnitude, TAB and TBA, they are equal in magnitude. they're equal in magnitude, just opposite direction. Okay. Okay, so we got the free body diagram already. Maybe we should draw separately. Yeah, this one you have two objects. You draw two free body diagrams separately. So I should put like this. I should put mass A, mass B. Yeah. So maybe this one I put as mass B. Okay, mass B. Or this is the mass 2. Okay, and this is the mass A. I put as mass 1. All right. Let's draw the free body diagram now. Yeah, draw the free body diagram now. Okay, so what's the free body diagram? Okay, first of all we draw, yeah, first of all we draw the axis. Yeah, we draw the axis, the x-axis for both. Yeah, and then we draw the y-axis. Sorry, the y-axis. Yeah. Okay, draw a point mass at the center. Point mass. Okay. Okay. So the mass B is these three forces. Okay, just copy that. All right, just copy that. So you have TAB. Here is TAB. Here is mass. You can put mass because it's mass B. You can put as weight B lah. You want to put as mass. Just put there. Follow the subscript. Maybe this time just follow the subscript. Yeah. Okay, never mind. So this is the weight B. Yeah, just put as weight B. And then this is the normal force. This is the sorry. Okay, hold on a second. Yeah. So here you have the normal force B. Yeah, normal force B. And then, okay, acceleration to the front. You must write the acceleration also. Acceleration to the front. Okay. And then how about the mass A? Mass A, you have 4 forces here. So you have 4 forces. First of all, you have the external force FP, which is how big is the force FP? FP is 40 Newton. Yeah, 40 Newton. 40 Newton. And then it has the weight. Okay, it has the weight A. Just put as weight A. This one is a normal force. Sorry, normal force A. Normal force A. And then you have the tension going behind. Yeah, tension going behind. This is a TBA. Okay, this is TBA. All right. So I think I got everything. Okay. So I need to draw the acceleration to the front also. Okay, acceleration to the front. So that's it. That's the free body diagram. Okay. So now how to do the questions? Okay. This mass A. This is mass A. Just put as mass. This is mass. This is for mass A. This is for mass B. Okay. So mass A just now, this is 10 kilogram. Okay. And then this mass B is 12 kilogram. Okay. Mass B is 12 kilogram. Okay. So now we need to find the acceleration. Okay. So for this question, we need to do one by one. Yeah. We need to find we have a x and y component to do for mass 1. We also have x and y component to do for mass 2. But you see, this one is a smooth surface. Smooth surface. So no friction, isn't it? No friction. So if because we know that friction, let's say kinetic friction, it is mu kn. So we only need to do y component. We only need to do y component if we need to consider the normal force. Sorry, if we need to consider the normal force and to find the friction. Right now, it is a smooth table. Smooth table, so no friction. So we no need to consider the friction, no need to consider the normal force. So in short, we can say no need do y component. Unless the question asks for normal force. unless the question asks for normal force of each block. But the question just asks for acceleration. Acceleration is the question just asks for acceleration. Acceleration is only in x component. You see that? Only x component. This acceleration only in x component. And the tension here, this is the tension in the cord. This one also in the x component. The tension also in the x component. So it doesn't involve the y component. You see that? It doesn't involve the y component because it's a smooth table. Smooth table is you don't need to find the friction. Okay, smooth table, you no need to find the friction. No need to consider no need to find the normal force. No need to find normal force because normal force only in the y component. But now you no need to find friction, no need to find normal force. That means no need to do y component. So what I can say is like this. Maybe let me draw for you. Okay, actually this one sorry, yeah. 1 second. Yeah. Actually this one is this one you can do x component and also y components, x component and also y components. Maybe let me draw for you. Okay, just a little bit. Yeah. Yeah. You can do x and y component for both, you know that. But since the normal force not needed because no friction, so we no need to do the y component. Okay, we no need to do the y components. We only need to do the x component. We only need to do the x component. Okay, but I will show you also, how to do the y components. How to do the y components. I will show you also. Just in case we have friction, you see, just in case we have friction. Okay, now let's look at mass A first. Mass A. Okay, so we can see here. Actually, this question just do the x component is enough. Okay, so look at the x component. Look at the x component. X component is total fx equal to m a, because in the x component we have the this is the x component, this is the x, this is the y, this is the x, this is the y. So in the x component we have acceleration. It has acceleration, so it's ma. But the y component, it is for the y component it is 0 because no acceleration. Okay. So before you continue, you must put the positive negative sign first. Remember, if you have ma acceleration, if you have acceleration, you need to compare with acceleration. Follow acceleration. Look at this one. In the x component, we have acceleration, isn't it? So you need to follow this one. Follow acceleration positive, opposite acceleration negative. So this one, follow acceleration to the right. You have positive. Opposite acceleration to the left, it is negative. But for y component, no acceleration to compare. Y component is total f equal to 0. So we just use this one. Total fy, which is 0. So just put going up positive, going down negative. No acceleration to compare. So just put going up positive, going down negative. That's it. Okay. So now let's do go back to the x component. Now, so for x component we have this fp. Okay, fp which is positive. Just put positive. This is a positive fp. Positive fp. Positive pulling force. You know, fp is pulling force, and then tension is negative. Tension is negative. So just put that as a negative tension, tension B, BA equal to, this is a mass what? Mass A, isn't it? This is mass A. I forget to put mass A. This is mass A, so which is 10 kilogram. 10 kilogram A. How about the y component? Y component is going up positive, going down negative. So that one is you know, positive and A, positive and A, and then negative WA, negative WA. So that one, for y component, you can find the normal force. The weight is 10 weight is mg, which is 10 times gravity. Yeah, 10 times gravity. So you can find normal force from here, which is which is 10 times gravity. You can find normal force for this one, but the question doesn't seem to need to find the normal force. Now look at the x component. So we have this one. The pulling force is 40 Newton. Okay, 40 Newton. So put 40 minus the TBA equal to 10A. Okay, so we have two unknowns here. You see that? We have the tension and we have the acceleration. So we need another equation to solve these two variables. So we need to look at the mass B now. Look at the mass B. Okay, this is the mass B. So we also do the x and y components. Very simple. Okay, the acceleration only exists in the x component. So in the x component is total fx. Total fx equal to m. This is mass B. So we put as mass B A. We put as mass B A. Okay, mass B A. Okay, that's it. So this force, but y component has no acceleration, so we can say total Fy equal to 0. Total Fy equal to 0. Now, don't forget to put the positive negative sign. So in x component, we have acceleration to compare. So follow acceleration is positive, opposite acceleration is negative. But y component, no acceleration, so we just put going up positive, going down negative. That's it. Okay, so now look back to x component. So we have TAB going to positive direction. TAB is positive because it follow acceleration. Okay, follow acceleration, so it's positive TAB, positive TAB. And then mass B is 12 kilograms, so it's 12A. So it doesn't have any negative force. Yeah, no force in the opposite acceleration. No. So just TAB only. Okay. And then for y component, and normal force is positive, weight is negative. So we can put positive the normal force, and then negative the weight. Okay, so here we can get normal force equal to the weight B is 12 kilogram. The mass is 12 kilogram, so this is 12 G. Yeah, because this one is 12 gravity. Understand? This is 12 gravity. So here you can find normal force for B, but not necessary because no friction to find. Okay, no friction to find. No need to apply the mu Kn. So okay, so here also we got the two unknowns, TAB and A. You see that? So here we have two equations. You see that? We have two equations. We have equation, just like equation 1. This one equation 2. So and then another thing is TAB is TBA. You see that? So we can apply this formula. TAB is what? Equal to TBA. So this one is equal, TAB is equal to TBA. So we can substitute this one into here. Okay, substitute one into here. So we can substitute the 2 into 1. Subs the 2 into 1. So okay, let's continue. So we have so 40 minus what? TBA is TAB. No need to put negative sign, because this one actually just consider the magnitude only. Just put magnitude. Don't go to become here, you substitute become negative 12a. No, no, not such thing, not such thing. No negative sign, no negative sign. Okay, don't substitute because TAB and TBA, they are opposite direction. So that means you must put a negative sign inside. No. Okay, we just subs magnitude. We just subs what? We just subs the 12a only. Subs 12a only. Understand? Subs 12a only, not the negative 12a. Okay, so just subs the 12a. Okay, remember, just subs the 12a. So it becomes what? 12a into it becomes what? It becomes the negative already in front. Okay, so you just subs 12a inside. Okay, see, I just subs 12a, not negative 12a. I just subs 12a. Okay, and then continue. Okay, and then this one go to the other side, become positive. So become 40 equal to 22a. So what is the acceleration in the end? Acceleration in the end, you got 40 divided by 22, which is equal to it is equal to 1.82 meter per second square. That's the answer. 1.82 meter per second square. Okay, that's correct. Yeah, 1.82. Is that correct? Yes, it's correct. 1.82. Good. Yeah, good. Now that's for question A. Now how about question B? This is for question A. Question B asks for the tension. The tension, that means this is the tension, this is the TAB or TBA. So you just substitute back into equation 2 and you can find the answer. So equation for question B, you just find the what? You just find the from back to equation 2. Back to equation 2, TAB is equal to 12a. You already got the a, just substitute the a, which is equal to, which is acceleration, this one, which is equal to so just substitute 12 times 1.82. what do you get? So I got 21.84 Newton. Is that correct? 21.84. This one will also be equal to TBA. Understand? Because they are action reaction force. They are action reaction force. Action reaction force. Okay. So 21.84. Is it correct? Yes, 21.8. Or 21.84. That's correct. Yeah, 21.8 or 21.84. That's correct. Okay, that's the tension. That's correct. Okay. Now, there is actually one shortcut to find acceleration. If the question just asks to find acceleration and without asking the tension, actually there's one shortcut to find acceleration of each box. Let me tell you how. You can ignore the tension. You can ignore the tension and then combine these two objects as one object. That means what I can say is it's like this. It's like this. You have the surface here. Let me just draw it for you first. Okay, I already draw for you. As you can see in the x component, yeah, we only need to do the x component. The surface is smooth, so no friction going behind. I know that in between that, in between the masses, we have the tension, isn't it? We have the tension. This is tension AB. This is the tension. This is the tension BA. Tension BA. So, but these two forces you can ignore because they like cancel each other. So you can ignore them. So you can treat the whole system as one object. You can treat the whole system as one object. Okay, as one object. Yeah, can treat the whole system as one object. So just this. So let us do the fast way. If just to find the acceleration, you cannot find the tension with this way. Yeah, this way is only to find the acceleration, but you cannot find the tension. If you want to find the tension in between the block, you need to do two separate free body diagrams. You need to do two free body diagrams separately. Separate them, only we can find the tension in between. And you can find the acceleration. You can find acceleration and also the tension in between. The tension in between. But if you combine both, you cannot find the tension in between, but you can find the acceleration only. In a faster way. Okay, let us just find the acceleration if the question asks to find acceleration only. Okay, so how? So this is a total Fx equal to mass total. This is not just one mass. This is not just individual mass, but this is the total mass of both because we combine it as one object. Okay, so what is the forces exist? The forces exist in the x component, no friction, isn't it? If got friction, you need to put inside. Yeah, if got friction behind, then we need to include the friction. Okay, but no friction here, no need to include lah. Forces going, you see, also follow the same system. If got acceleration, follow acceleration, positive, opposite acceleration, negative. So as we say that follow the acceleration is a positive force, opposite the acceleration is a negative force. Like you see, if the question is a rough surface, if it is a rough surface, we have friction, then you need to put a negative Fk. But this time we don't have the friction, so we can remove that. Yeah, we don't have the friction, so it's easy. We only have one pulling force to the front. Okay, these two tension we can consider they cancel each other. So no more tension. Okay, just the pulling force. So the whole system actually, mass A and mass B both combined, actually all of them are pulled by one single force, which is the pulling force 40 Newton. So only one force in the x component. So we put that as a positive 40 because it is a follow acceleration. Okay, or we can say positive pulling force. Okay, equal to mass total is mass A plus mass B. Mass A plus mass B acceleration. So this one is a 40. Okay, and then each mass, this is 10 kilogram. This is mass B is 12 kilogram. Acceleration. So let's find the acceleration this way. So acceleration this way is equal to, let's calculate. Okay, 40 divided by 22. I got the answer 1.82 meter per second square. Fast and easy. And the answer is correct. Okay, same like before. Okay, same like before. So that's but you can only find acceleration if you combine both. You can only find acceleration if you combine both. You cannot find the tension. If you want to find the tension, you need to do separately. Okay, to combine, we only can find acceleration. That's it for this question. Bye.